Okay, sincerest apologies about that. Let me know if you guys can hear me all right now. Walaikum salam. So, can you guys hear me now? Walaikum assalam. Okay, now. Secondly, could you sum up the benefits of AdMaths and why some people give it? Because the course. Okay, I'll make a video on that about AdMaths. Okay, it's in my to-do list. Don't worry about that. Sir, मैंने आपसे पूछना था. Do you give? No, I don't give classes for further math. I'm sorry about that. Sir, how do you know? Okay, I have no idea what that is. I don't even know how to pronounce it. Alaikum salam. Okay, Chane, let's get to work. I say, how's the preparation coming along? I hope everything's on point. How much time do you guys have? February, March, April. Let's not count May. So you have 2.5, 3 months. Thanks, sir. I hope it's. सर ए स्टार लेना ही पड़ेगा बगैर प्लीज़ बताएं कैसे लूँ पढ़ के 80 days. Yeah, that's what I thought. Sir, do you have any idea about hyperbolic geometry? I do. Yeah, I do have an idea. But like, what do you want to know about hyperbolic geometry? Okay, it's okay to be scared at this point. In fact, you should be scared. It's not easy. If anyone tells you it's easy, well, they're probably lying or they don't realize how difficult it is. So you should be scared. In fact, it is only that which is going to help you prepare. अगर आप डरेंगे नहीं तो फिर ज़ाहिर है आप पढ़ेंगे कैसे? So it's important that you're scared. But the thing is, just don't be scared. Do something about it. Okay? When you sort of start solving yearly past papers, that is when you will realize where you stand. And when you do enough yearly past papers, you gradually get a grip on everything. So it's very important that you do yearly past papers. Okay? I will inshallah also be starting a stream of yearly past papers. So that's where we'll solve past papers together. Okay? Alright, sir, मैथ्स के पेपर में नींद आ जाती है तो बेटा सो के जाया करो ताकि पेपर में ना नींद आए. सर आप जनरली आप अच्छे टीचर हैं. थैंक यू, आई अप्रिशिएट दैट. सर बिग प्रॉब्लम कि आई एम नॉट स्केयर, टेंशन भी नहीं हो रही. ओके, दैट इसका मैं कोई जवाब नहीं दे सकता. वेल, आई थिंक आपको इस बात की टेंशन होनी चाहिए कि आपको टेंशन ही नहीं हो रही. ये एक टेंशन लेने वाली बात है. Sir, can you recommend me about any advanced calculus books? No, I've been completely out of that. Acha, anyway, chalo, let's get to work. Okay, so I will take questions once sort of I start explaining. Okay. Acha, now, so basically here's number sequences and patterns. This video hopefully will be the only thing that you need to watch for number sequences. Okay, so this stream is going to go up for like an hour, hour and a half, could be even 2 hours. Okay, so what you can expect, or what are the type of sequences that you can expect? Well, the first is very basic, and that's an arithmetic sequence. Okay, arithmetic sequence, or it's also called a linear sequence. Okay, arithmetic or a linear sequence. Okay, so you can expect this. The second is a quadratic sequence. Okay, and then you have an exponential sequence. Okay, exponential sequence. और ये मैं नहीं कह रहा, ये syllabus में रखा हुआ है. ठीक है. And then you have something called a cubic sequence. Okay, now, well, cubic sequence is something that's written in the syllabus. Okay, but I haven't seen it anywhere. Okay, So I'll show you. I have screenshots of the syllabus. So this is something that we're going to do later. Okay, we will cover arithmetic sequence, we will cover quadratic sequence, inshallah, we will cover exponential sequence. Okay, but cubic sequence is part of the syllabus. I have never seen it. I've never seen a question on it. Okay, so I'll make a separate video on it in case it pops up. Okay, yes, exponential sequence is also called a geometric sequence. Okay, and then you have something called like a hence find or pattern recognition. Okay, where you're given a certain sequence, okay, and you're asked to, with the help of the general term of that sequence, you're asked to determine the general term of some other sequence. Okay, so here's a syllabus, and the syllabus is more or less the same for IGCSE. So you can see that it says here, yeah, so it says here linear, which is same as arithmetic, quadratic, cubic, exponential, or simple. So here, notice how it says cubic sequences, and it says including expressions for the nth term. So this is the O-level syllabus, and here's the IGCSE syllabus. Here you can see you have linear, quadratic, cubic, exponential sequences, and simple combinations of these. Okay, and here also you're supposed to be able to determine the nth term of each sequence. Okay, now I will attach the link to this PDF once we're done. Okay, right now it's too soon because I haven't really done anything. So once we're done taking all the notes and everything, I'll attach a PDF to this. Okay, now let's start with arithmetic sequence. Okay, now what makes a sequence an arithmetic sequence? Let's have a look at that. Okay, so let's say that you have a set of terms such as 3, 5, 7, 9. Okay, so if I ask you guys to tell me the next couple of terms of the sequences that I'm writing, you should be able to tell me, and I'd like you guys to do that. Okay, and then let's say that we have 15, 11, 7, okay, 3, yeah. So tell me the next 3 terms of both the sequences. Okay, and then let me write another one. Let's say that you have -5, -2, 1, yeah, there you go. 11, 13, 15, that's correct, good job. 11, 13, 15. Yes, we just started, nothing to worry about. And then what about the next one? 11, 13, 15, that's correct, good job. -1, -5, -9, that's correct. -1, -5, -9, good job. And then this one I'll write myself. Okay, we'll save some time. So what we're doing here is we're consistently adding 3. Okay, so -2 plus 3 is 1, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. Okay, perfect. So basically, these type of sequences are your arithmetic sequence. Okay, now the question is, why do we call these sequences an arithmetic sequence? So to keep it short and simple, in an arithmetic sequence, the difference between consecutive terms is common, and that's what we call the common difference. Okay, common difference, which is denoted by the letter D. Okay, so what you do is you pick any pair of consecutive terms. Okay, so it has to be consecutive. All right, so let's say I pick these two. So what's the difference between 7 and 9? 2. Let's say I pick these two. What's the difference between 11 and 13? 2. Say I pick these two. What's the difference between 13 and 15? 2. Okay. So and that's what we're doing. We're consistently adding 2 in order to get to the next term. That's why this sequence has common difference of 2. Okay. Now let's look at the next one. What's the difference between 15 and 11? -4. Okay. Or in other words, what are you doing in order to get to the next term? You're subtracting 4. Okay. And that's what you're consistently doing. So the common difference in this case is -4. Okay, and here what are you doing in order to get to the next term? You're consistently adding 3, and that's why the common difference of this sequence is 3. Okay, now let's pick the second sequence, for example. Okay, so you have 15, 11, 7, 3, okay, minus 1, minus 5, minus 9. Okay, so it's important to understand the notations that we're going to be using in this. Okay, so 15 is the first term, so we'll write it as T1. 11 is the second term, so we'll write it as T2, T3, T4, T5, T6, T7. And let's say, just like that, you're asked to write down the 50th term. Okay, let's say you're asked to write down the 50th term. Okay, now one way would be to write down all the terms till you get to the 50th term. Okay, but that would be very time consuming, and honestly speaking, that would be very stupid to do that. Okay, so what we do is we learn something called Tn. Okay, so Tn is basically something that we call the general term. Okay, and that's a formula which will then allow you to find out whatever term it is that you want. Okay, so you'll have a formula in which you can plug in 50, okay, and that will give you the 50th term, or you'll have a formula in which you can plug in 70 and you'll have the 70th term. Okay, so that's what we're going to do. So in order to find out the nth term of an arithmetic sequence, here's the formula that we use: a plus n minus 1 into t. Okay, so this is what we use in order to find out the general term, okay, of an arithmetic sequence, where a is what? A is the first term, okay, n is the required term, and d, as we saw earlier, is the common difference. ठीक है, अब यही sequence लेते हैं and let's find out the general term of this sequence. Okay, so let's write down the first three terms again. Let's say we have a 15, 11, 7, 3. Okay, so how will I find out the general term of this sequence? How will I find out Tn? So here's T1, here's T2, here's T3, and here is T4. This is the formula that I'm going to use. Tn equals a plus n minus 1 into d. What's a? A is 15, and what's the common difference in this case? The common difference in this case is minus 4. Okay, so that's what we're going to do. For the general term, we'll do 15 plus n minus 1 times minus 4, and let's see what we end up with. So we end up with 15 minus 4n plus 4. So be careful of the multiplication. Okay, you don't want to make any sign errors here. So Tn equals to 15 plus 4 is 19, 19 minus 4n. Okay, now when you have the general term, always test it. Okay, don't just walk away from it, but make sure to test it. Okay, so what's the sequence that we have? The sequence that we have is 15, 11, 7, and 3. 7, 3. In fact, we have minus 1 and minus 5 also. Okay, so minus 1, minus 5. So if I plug in, let's say, if I plug in 6, so technically the sixth term should be equal to what? Should be equal to minus 5. Okay, so if I plug in 6, technically we should be able to get minus 5. So let's see if that's the case. So 19 minus 4 into 6. So 19 minus 24, is 19 minus 24 equals to minus 5? Yep, it is. So minus 5 equals to minus 5. That means the formula is correct. And just like that, if you want to be absolutely sure, try for some other value also. Let's say the fifth term. So if the fifth term is minus 1, let's see if our formula actually gives us minus 1. So 19 minus 4 into 5. Let's see if this is equal to minus 1. So 19 minus 20 equals to minus 1. Yep, minus 1 equals to minus 1. So that means that the general term is correct. Okay. Okay. Yes, ये stream बिल्कुल post होगी. Don't worry about that. Streams for AS I will do later on. Okay. So we'll, from the coming week, I'll try and do a stream for O-level math, add maths, and AS. Okay. All right. Do we have to simplify? Yes. Make sure to simplify. Okay. Make sure that you simplify your final answer. Okay. All right. So what we're going to do is we're going to do past paper questions along the way. Okay. So here's how to find the general term of an arithmetic sequence. Okay. And I'm going to do a few more questions and then we'll do past paper questions along the way. Okay. All right. So let's take this sequence here. So let's say that you have the following sequence. Let's take the first sequence, 3, 5, 7, 9. Okay. So let's say you have 3, 5, 7, 9, 11. Okay. And here's what we do. We have to, in part A, find the general term. Okay. Find the general term. So this you can say is example number 2. And what we did here was example number 1. Okay. Find the general term, and let's say there's a part B to this question which says find T50. Okay, that means find the 50th term. Okay, and let's say there's part C which says T of P equals to 107. Okay, and you're asked to find P. Okay, so let's start with part A. Let's put this here. So finding the general term, let's write down the terms here. So we have 3, 5, 7, 9, 11. So you can see that the first term is 3. And what's the common difference? What is the difference between these two terms consecutively? So how do you go from 3 to 5? You add 2 to it. Okay, and how do you go from 5 to 7? 2. So that means the common difference is 2. Okay, now all you got to do is plug in these values. So Tn, it's always a good idea to write down the formula a plus n minus 1 into t. So Tn is equals to 3 plus n minus 1 times 2. So Tn equals to 3 plus 2n minus 2. Again, be very careful with the signs. So there you go, 2n plus 1 is your final answer. Okay, so yeah, that's it. That's the answer to part A. Okay, now let's do part B. Part B says find T50. So what does that mean? T50 basically means 50th term. Okay, T50 basically means 50th term. So now that I have the formula for general term, that's pretty much all I need in order to find out the 50th term. So T50 equals to 2 times 50 plus 1. So T50 is equals to 2 times 50 is 100, 100 plus 1 is 101. Okay. All right, now what's the difference between part B and part C? Question for you guys. What's the difference between part B and part C? Yes, in part B, we are given the value of the term, okay, and we have to find out what term number is 107. Okay, so that's the difference. All right, so Tp equals to 107 basically means that if you were asked to find the pth term, you would do Tp plus 1. Okay, and what is this equal to? This is equal to 107. All right, so 2p equals to 106, and what's p is equals to? P is equals to 53. And there you go. That's it. That's your answer to part C. Okay. I can see that you guys are fighting amongst yourselves. Yeah, not surprised. Yeah. All right. So like I said, we're going to do some past paper questions along the way. Okay. So here's a question. This is from October, November 2011. All right. And it basically revolves around arithmetic sequence. So let's do it. So it says a series of shapes made of matchsticks is shown below. Okay. Draw shape 4. All right. So let's see what we need to do in shape 4. So, okay, I appreciate that. 1, 2, 3. So let's start with the base. Okay. So you have 3 matchsticks, you can say, in shape 1. You have 1, 2, 3, 4. 4 matchsticks in shape 2, and 1, 2, 3, 4, 5 matchsticks in shape 3. Okay, so how many matchsticks are we going to have as our base? If you follow the sequence, you can see that you have 3 here. Oops, sorry about that. You have 3 here, you have 4 here, and you have 5 here. Okay, so how many are going to have now? You're going to have 6. Okay, so let's draw the shape. So 1, 2, 3, 4, 5, 6. In fact, you know what? I'm going to draw it with the help of freehand pencil. So that's 1, 2, 3, 4, 5, 6. And let's make dots here so that they actually look like matchsticks. So 1, 2, 3, 4, 5, 6. Okay. Now let's talk about the height. Okay. So this height is 2, this height is 3, this height is 4. So that means in shape 4, the height is going to be 5. So 1, 2, 3, 4, 5. Okay, and then from this point onwards, it's pretty much the same thing. Okay, so there you go. 1, 2, 3. Okay, there you go. Let me make sure that I've done it correctly. So 1, 2, 3, 4, 5. No, wait a minute. I think I've drawn an extra line. No, wait, it's fine. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, so it's correct. Okay. All right. Now, then it says the table shows the number of matchsticks used to make shape 1 and shape 2. Okay. The number of matchsticks in shape 1 is 12, number of matchsticks in shape 2 is 18, and let's count the number of matchsticks that we have in shape 3. Okay, so let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so we have 24 matchsticks in shape 3. Okay, and now you don't really have to count how many matchsticks you have in shape 4. You can just follow the sequence that from 12 to 18 you go by adding 6. From 18 to 24 6 ऐड किया, 24 से फोर्थ वाले जो शेप होगा उसमें 6 ऐड करेंगे तो कितना आएगा, 30 आएगा. ठीक है, अगर आपको दिल करे तो आप इसको काउंट करके भी लिख सकते हैं. ठीक है, लेकिन save some time, follow the sequence, and that's it. Okay, there you go. Then it says find an expression in terms of n for the number of matchsticks used to make shape n. So what is the question asking here? The question here is asking you to basically write down the nth term. Okay, so that's what we're going to do. Let's write down the terms that we have. So we have 12, 18, 24, and 30. So you can see that the first term is 12, and you can see that the common difference in 6. And there you go. Tn equals to a plus n minus 1 into d. So Tn equals to 12 plus n minus 1 into the common difference, that's 6. Now let's write this down. 12 plus 6n minus 6. 12 minus 6 ho gaya 12, and 12 plus 6n is your final answer. Okay, and there you go. Now make sure that you always check your answer. So if I plug in 3 over here, answer kya aana chahiye? 18, 24 aana chahiye. So let's see, 12 plus 6 into 3, is it equal to 24? So 6 into 3, no, wait a minute, kuch garbad to nahi ki? Oh, 12 minus 6, 6 hoga. See, acha wana check kar liya. That's what I meant, ki aap check kiya kare. Okay. So 6 plus 18, is this equal to 24? Yes, it is. 24 equals to 24. There you go. That's it. That's the answer. Okay. O-levels is quite easy as compared to A-level. Okay, good for you. So add maths polynomial. Yes. Okay. I already have a few videos on polynomial, by the way. Sir, can't we just write the answer by calculating the difference between two terms? Yes. So if you're talking about this table here, so the only way that you're going to be absolutely sure about the pattern is when you have like enough terms. Okay, so if 2 terms take care, you can't see what the pattern is. So you got to have at least 3 terms so that you're absolutely sure of the pattern. Okay, Sir 6n, yeah, I fixed that. P1 mein aata hai. Okay, yeah, this usually comes in P1. Okay. All right. Then it says explain why there is not a shape that is made of 100 matchsticks. Okay, 100 matchsticks, that means we're talking about the total number of matchsticks. So let's see if it's possible to have a shape with 100 matchsticks. So in that case, 6n plus 6 would be equal to 100. Okay, we don't know what shape number it is, but it's got to be equal to 100. So 6n equals to 100 minus 6. What's that equal to? That's equal to 94. And let's see if 94 divided by 6 is possible. 94 divided by 6, it's not possible. Okay, so What explanation do you write? You write this explanation that 94 is not a multiple of 6, and that's it. Okay, no extensive explanation needed, just keep it short and to the point, and that's it. Sir, please skip linear sequences. Oh, I can't do that. I can't just go totally skip linear sequences. Okay. All right. Now, here's another question. Let's just quickly solve this question, and then we have. Okay, I'm going to skip a few questions. I think it's fair to do that. You guys can attempt them on your own, and then we'll start with quadratic sequence. Okay. Okay. So it says here, complete the table. You have pattern number. So let's count the number of dots that we have in pattern 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 dots in pattern 3. Okay, and you can pretty much follow the sequence now. So 5 से 8 कैसे गए, 3 add करके, how do you go from 8 to 11? By adding 3, and then if you add 3 to 11 you get 14, and then if you add 3 to 14 you get 17. So there you go. Okay, and then it says find an expression in terms of n for the number of dots in pattern n. So 5 plus n minus 1 into 3, which means 5 plus 3n minus 3, and the answer is 3n plus 2. There you go, 3n plus 2 is your final answer. And then it says in this sequence pattern P has 83 dots. So what we do is 3n plus 2, we set it equal to 83, and then 3n equals to 83 minus 2, which is 81, and n is equals to 27. There you go, that's your answer, 27. Yes, this stream will be uploaded later on, so don't worry about it. Okay, now this is the last question of arithmetic sequence that I'm going to do, and then we will move on to quadratic sequence. Okay. So it says here are the first 4 terms of a sequence. Write down an expression in terms of n for the nth term of the sequence. How do you go from 7 to 11? You add 4. How do you go from 11 to 15? You add 4. How do you go from 15 to 19? You add 4. Okay, and what's the first term? It's 7. So 7 plus n minus 1 into the common difference. So you have 7 plus 4n minus 4, which is equal to 4n plus 3. And there you go, 4n plus 3 is your final answer. Okay. Okay. Then it says in part B, un is the nth term of another sequence. So this is a slightly different question. Okay. Here is the formula connecting the nth and the n plus 1th term of the sequence. The value of u3 is 11. Find u2 and u4. Okay. Now, so first of all, it's important that we understand what's given here. Okay. So notice over here, if you plug in, let's say if you replace un by the 5th term, okay, hypothetically speaking, if you plug in un by the 5th term, okay, what you end up getting is the term right after the 5th term, which is the 6th term. Okay, so notice that you have n here and you have n plus 1 here. So whatever you replace un with, you end up getting the term right after that one. Okay, so let's say if you replace, again, hypothetically speaking, let's say if you replace un by u3, what you end up getting is the term that comes right after the 3rd term, which is the 4th term. Okay, I'll repeat. If you replace un by u3, what you end up getting is the 4th term, because that's how this sequence works. Whatever you multiply 3 with and subtract 4 from it, you end up getting the term right after that one. Okay. So what we do now is that we plug, notice that what do we have to find? We have to find the 2nd term and the 4th term, and what we're given is the 3rd term. Okay, we're given that the 3rd term is equal to 11. Okay, so what we do now is we replace u3 with 11, since the 3rd term is 11, and then if you solve this, we end up getting the 4th term. Okay, and what's the 4th term equal to? The 4th term is equal to 33 minus 4, which means that the 4th term is equal to, what's 33 minus 4? 29. And there you go. We now have the 4th term. Okay. Now the question is, how do we find the 2nd term? How do we use this sequence to find the 2nd term? Okay. Now pay close attention. Notice that here you always get what? Here you always get the term that comes right after this term. Okay. So let's say if I plug in u3 over here, what you get is the 4th term. If you replace un with the value of the 3rd term, you end up getting the 4th term. if you replace the value of un by the second term, okay, if you replace un by the value of the second term, what you end up getting is the third term. All right, let's see. 3 times u2 minus 4 is equals to u3. And notice what we have here is the third term. And what's the third term equal to? The third term is equals to 11. So 3 times u2 minus 4 equals to 11. If we solve this equation, so 3 times u2 equals to 11 plus 4, which is 15. And what's u2 equal to? u2 is equals to 15 upon 3, which is equal to what? Which is equal to 5. And there you go. Now you have the second term. Now take a good look at what I've done. Let me know if you have any questions. In the meantime, I'll reply to your messages. Sir, AS math normal distribution. What about it? AS math normal distribution. Okay, I will inshallah make videos for AS hopefully by the end of this month. Okay. Yes, this stream will be posted. Don't worry about it. Okay, the stream will be posted. Okay. Yes, Ahmed, I've read your message. I will inshallah make videos on M1 soon. Okay. All right, moving on. So I'm going to skip a few questions here. Okay. You guys can attempt them on your own to follow the same sequence. Okay. All of them belong to arithmetic sequence. Okay. And now I want to do quadratic sequence. Okay. Now, first of all, as we did earlier, I'm going to write down a few terms, okay, and I want you to tell me the next couple of terms, okay. So here's the first term. So let's say that you have 6, and then you have, let's say, 8, and then you have 12, and then you have 18, okay. And now I want you guys to tell me the next 3 terms, okay. And then let me write down another sequence. Let's say that you have 1, and then let's say that you have 4, and then let's say that you have 9, and then 16. Yeah. Okay, the link for the worksheet I'll attach towards the end, okay, because I'm taking notes in the same file. Okay, so can you guys tell me the next set of terms here? (24, 36, 48) I think is the correct answer. But anyway, let's figure it out. So basically, what you have to do is you have to follow the pattern here. Okay. So how do you go from 6 to 8? You add 2. Okay. How do you go from 8 to 12? You add 4. How do you go from 12 to 18? You add 6. Okay. And then if you follow the same sequence, how will you go from 18 to the term that comes right after? You're going to add 8 to it. Okay. And what's 18 plus 8? That's 26. And then how do you go from the term that's after 26? You're going to add 10. So that's 36. And then you're going to add 12. Okay, so what's 36 plus 12? That's equal to 48. Okay. Now, what makes this a quadratic sequence is the following, that the difference between the difference is the same. Okay, so the difference between the difference is the same, which, by the way, we'll see that is called D2. Okay, the second difference, D2, which is the second difference. All right, what about this one? 1, 4, 9, 16. What are we going to do in this? This is pretty easy if you think about it. How do you go from 1 to 4? You add 3. How do you go from 4 to 9? You add 5. How do you go from 9 to 16? You add 7. And then if you look at these terms, okay, 1, 4, 9, 16, you'll realize that they're basically perfect squares. Okay, 1 is a square of 1, 4 is a square of 2, 9 is a square of 3, 16 square of 4, and then the next term that you're going to have is 25, 36, 49. Okay, and here also you can see that the difference of the difference is the same. Okay, it's 2 here, it's 2 here, and it's 2 here also. Okay, now these type of sequences are basically called your quadratic sequence. Okay, and what makes a sequence a quadratic sequence? It is when the difference between the difference between the difference, okay, is the same. Okay, and we have this in past papers. Not a lot of people pay attention to it, okay, but it's important that you know how to find the general term of this sequence. Okay, and when I write down the formula, chances are that you will freak out, but bear with me. You will see exactly how this works. Okay, so the formula for calculating the general term of a quadratic sequence looks like this: a plus n minus 1 into d1 plus d2 upon 2 into n minus 1 into n minus 2. Okay, now I know this looks scary. Okay, it is scary at first. Okay, but you will get the hang of it. Don't worry about it. All right. Now the question is, what's a and what's d1 and what's d2? So a in this case is also your first term. And by the way, there are many ways to calculate the general term, but this is the way that I prefer. Okay, it's the easiest and the most efficient. And d1 is basically the difference between first two terms or you can say the first difference, ठीक है. And what's d2? d2, as we saw, is the difference of the difference. Okay, now let's put this formula to the test and see if it really works. Okay, so I'm going to go back to the very first sequence. All right, here's an example, which was 6, 8, 12, 18. 6, 8, 12, 18. Okay, and let's see if this formula really works. Now, in this case, what's the first term? The first term you can see is 6. Okay, what's the difference between the first two terms? Okay, what's the difference between 6 and 8? That's d1, and that's equal to 2. Okay, so that's 2, 4, 6. And what's the difference of the difference? The difference of the difference is also 2. Okay, now don't make it a rule that the difference of the difference will also be 2. Okay, or will be the same as the first difference. This is just a coincidence. No, you don't need to understand where the formula comes from. Okay, don't worry about that. I'll make a video on where the formula comes from in case you're interested in finding out. Okay, but you don't have to worry about that. So now all we have to do is just put everything together. Okay, so here's the formula: a plus n minus 1 into d1 plus d2 upon 2 into n minus 1 into n minus 2. Okay, so a is 6 plus n minus 1 into the first difference, which is 2, plus 2 upon 2, and then what you can do is you can expand n minus 1 and n minus 2 and write down the expanded version. So n square minus 3n plus 2 is what it ends up becoming. So we have n square minus 3n plus 2. Okay, so this 2 and this 2 gets cancelled out. So now we have a lot of simplification to do. So 6 plus 2n minus 2 plus n square minus 3n plus 2. So this minus 2 and this minus 2 also gets cancelled out, and now you have the general term, which is n square minus n plus 6. Why? Because 2n minus 3n is minus n, and then you have a plus 6, which you can't simplify with anything else. Walaikum salam. And there you go, that's it, that's your answer. N square minus n minus 6 is your answer. Now, when you get your answer, make sure to put it to the test. Okay, you don't want to leave it like that. And if you put it to the test, let's say we calculate the third term. Okay, so technically the third term should be equal to what? Technically the third term should be equal to 12. Okay, let's see if that's the case or not. So third term means 3 square minus 3 minus 6. Actually not minus 6, it's plus 6. So we have 9 minus 3 plus 6. So 9 minus 3 is 6. 6 plus 6 is equals to 12. So the third term is in fact equal to 12. That means what we have done so far is spot on. Okay, and if you want, you can also check this for the fourth term. If it's equal to 18 or not, you'll notice that it is equal to 18. And that's it. There you go. So how are you going to remember this formula? Well, you do 4 or 5 questions and you write down this formula 4 or 5 times, and I can guarantee that you'll have this formula memorized. You know, just how you have the quadratic formula now memorized, I'm sure you have this formula memorized also. Sir, what does invariant mean in transformation? So invariant beta एक concept होता था share or stretch में, ठीक है? It's no more part of our syllabus. So whenever you see invariant, I hope you're talking about O level या IGCSE math, ठीक है? तो invariant line, invariant वो वाला concept हमारे इसमें नहीं है, ठीक है? लेकिन invariant point है, okay? Invariant point is that point that remains unchanged after you apply the transformation, ठीक है? Okay, now, so here are some example questions that we're going to do. Okay, let's solve them together, and hopefully इससे आपको और formula बेहतर याद हो जाएगा, ठीक है? So let's say that you have this sequence over here. So and what we want to do is we want to find out the nth term of the quadratic sequence. ठीक है? So 5 से 11 पे कैसे गए? 6 ऐड करके. 11 से 19 पे कैसे गए? 8 ऐड करके. 19 से 29 पे कैसे गए? 10 ऐड करके. ठीक है? Now what's the difference of the difference? Difference of the difference here is 2. ठीक है? Make sure to write down the formula when you're doing the questions initially, so that you're able to memorize it. A plus n minus 1 into d1 plus d2 upon 2, and like I said, you can memorize the expanded version of n minus 1 and n minus 2, and that's going to be n square minus 3n plus 2. Okay, so what's the first term? You can see that the first term is 5. Okay, what's the first difference? You can see that the first difference is 6, and what's the second difference? You can see that the second difference is 2. Okay, so 5 plus n minus 1 into 6 plus 2 upon 2 n square minus 3n plus 2. Now from this point onwards, it's just simplification. So 5 plus 6n minus 6 plus n square minus 3n plus 2. So there you go. N square, nothing to be added or subtracted with n square, minus 3n. Okay, 6n minus 3n is plus 3n, sorry. 5 plus 2 is 7, 7 minus 6 is 1. So n square plus 3n plus 1 is your final answer. Let's write this over here. N square plus 3n plus 1 is your final answer. And there you go. That's it. Okay, so here are some questions that you guys can do later on as practice. Okay, I'm going to skip this. Achha, don't go for the marks. Okay, this is a separate worksheet. Okay, iske marks pe mat jana. Don't think it's going to be a 4-mark question. Ye bas ek separate worksheet hai. I compiled these questions for practice, and yeah, okay. All right, now these are some past paper questions which we're going to solve. Okay, and this is a question from October, November 2019. Okay, and this you will normally find in paper 2. Okay, which means that it has a lot of marks. Okay, so it says these are the first 4 patterns in a sequence made using counters. Okay. So you have pattern 1 with 3 counters, 2 with 8, 3 with 15, and 4. Let's count the counters in 4. So 4, 8, 12, 16, 20, 24. So we have 24 here. Okay. And then following the same sequence, can you tell me the number of counters in pattern number 5? P1, हाँ, clash का मैंने सुना. So best of luck to you. What about after 24? So 3 to 8, what do we have? We have 5, and how do you go from 8 to 15? You add 7, and then how do you go from 15 to 24? You add 9, and then you add 11, so what do you get? You get 35, there you go. Okay, now it says find an expression in terms of n for the number of counters in pattern n. Okay, so this is a 2-mark question, alright. So you have your first term, which is 3, you have your first difference, which is 5, and you have your second difference. You can see it's equal to 2. Okay. Now all you got to do is plug in the values, and let's write down the formula here, because we're not going to be given the formula, of course. Okay. So a plus n minus 1 into d1 plus d2 upon 2 n square minus 3n plus 2. Okay, so what's the first term? The first term is 3 plus n minus 1 into d1, which is 5, plus 2 upon 2 into n square minus 3n plus 2. Okay, now you have some simplification to do. So 3 plus 5n minus 5, 2 and 2 gets cancelled out, n square minus 3n plus 2. Okay, and then you can start writing down the final answer. So you have n square, 5n minus 3n will give you positive 2n. 3 plus 2 is 5, and 5 minus 5 equals to 0. And there you go, n square plus 2n is your final answer. And then as always, make sure to check your answer to make sure that you've done it correctly. Okay, then it says Ken has a bag containing 1, 3, 5, 8 counters. He makes the largest possible pattern in the sequence, pattern P, using these counters. Find the value of P. Okay, so what we found is a formula which will allow you to find the number of counters in the pattern. Okay, now we need to find out that what's the largest possible pattern that he can make with 1, 3, 5, 8 counters. Okay, so what we're going to do is n square plus 2n, we're going to set it equal to 1, 3, 5, 8. Okay, and what do we have? We have n square plus 2n minus 1, 3, 5, 8 equals to 0. And we're going to solve this using the quadratic formula. If you can do middle term breaking, that's great, but I don't think you can do middle term breaking over here. So I'm going to do it through a quadratic formula, and to save time, I'm going to do it in the calculator. So 1, 2 and minus 1, 3, 5, 8. अब n की हमारे पास दो वैल्यूज़ आ रही हैं, एक आ रही है 35.86 और दूसरी वैल्यू आ रही है minus 37.86. Now we're talking about pattern numbers, okay? And what do we know about pattern numbers? Pattern numbers have to be in integer form, okay? Decimal में नहीं हो सकते. अब ये है हमारा 35.86. अब आप लोग मुझे ये बताएं, ये p है basically, it's not n, it's basically p. So if p is 35.86, let me ask you guys a question. कि क्या हम 35 लेंगे या क्या हम 36 लेंगे? ठीक है, सोच के जवाब दीजिएगा. Is this going to be 35 or is it going to be 36? Yes, this stream will be posted. Don't worry about it. Okay, why 35? Why not 36? Even though 35.86 is closer to 36. Okay, 35 is the correct answer. Okay? Now the reason why we would take 35 and not 36 is because at 35.86 you're using all these counters. Okay, at 35.86 you are using all these counters. Okay, so we will have to go with 35. ठीक है, 36 लेने का मतलब है कि we will need more counters to make pattern number 36. ठीक है, so that's why we will go with 35. Okay, now it says he uses all of the remaining counters to make another pattern in the sequence pattern Q. Find the value of Q. Okay, now it says here he uses all of the remaining counters. Okay, so how do we find the remaining counters? ठीक है, तो ज़रा इसकी बात करते हैं. पहले तो देखते हैं how many counters does he actually end up using. कैसे? If n equals to 35, let's see the total number of counters that he ends up using. So 35 square plus 2 into 35. Why? Because Tn is equals to n square plus 2n. Okay, that's what we found out earlier. So let's work this out. 35 square plus 2 into 35. So 35 square plus 2 into 35. So that gives us 1295. Okay, so these are the counters that he has used. Now, how do I find out the remaining counters? For the remaining counters, here's what I do. For the remaining counters, we do 1358 minus 1295. So 1358 minus 1295, and that's equal to remaining counters is equal to 63. Okay, now what is he doing with these remaining counters? He is using these remaining counters to make another pattern. Okay, That means he is using these remaining counters n square plus 2n to make another pattern, which is equal to what? Which is equal to 63. So now what we do is we solve this equation, and let's not call it n square actually. He is using this to make pattern q, so let's call it q square. So q square plus 2q equals to 63, which means q square plus 2q minus 63 equals to 0. And then if you solve this, again I'm going to solve this using the calculator to save some time. Okay, make sure that you guys show you're working. Okay, I'm using the calculator to save some time. So you have q, which is equal to 7, or q, which is equal to minus 9. So what are we going to go with? We're going to go with 7. Okay, so now you may be wondering that this is a 2-mark question, and why is there so much working required for a 2-mark question? Okay, now what you could have done is, once you figured out the remaining counters, you could have directly given q equals to 7. How? By just carrying out this sequence further. Okay, so if you, let's say, find out the number of counters required for the 6th pattern, so you would do 35 plus 13. Okay, 35 plus 13, which is equal to what? Which is equal to 48. And then you would then do 48 plus 15, which is equal to what? Which is equal to 63. Okay, so here's what you could have done instead of doing the quadratic formula all over again. Okay, now here's another question of a quadratic sequence. Okay, and once we're through with this, then inshallah we'll start exponential sequence. Okay, so it says here the diagram below shows the first 3 patterns in a sequence. The patterns are made from short diagonal lines. All right, so let's see how many diagonal lines that we have in pattern number 1. We have 1, 2, 3, 4. And how many do we have in pattern 2? You can see here that you have 10, and in 3 you have 18. Okay, if I follow the sequence, how many pattern lines do you think we should have in pattern number 4? How do you go from 4 to 10? You add 6. How do you go from 10 to 18? You add 8. How will you go from 18 to the next pattern? You're going to add 10, which is 28. And then how will you go from 28 to the next pattern? You're going to add 12. So 28 plus 12 equals to what? Equals to, whoops, sorry, not 30. In fact, it's equal to 40. Okay, now comes the difficult part, and that is making this pattern. Okay, so I'm going to make this pattern now. So how many diagonal lines do we have here? 1, 2, 3. So that means in this one we're going to have 5. So 1, 2, 3, 4, and 5. Okay. No, wait, not 5. Actually, we're going to have 4. Yeah, 1, 2, 3, 4. Okay, and then 1, 2, 3, 4. Okay, and in the at the inside, how many do you have? You have the same 1, 2, 3, 4. Okay, so that's correct, I guess. Yeah, 1, 2, 3, 4, 5. 1, 2, 3. Okay, wait a minute. Let's start from the beginning. So let's start from here. So you have 1, 2, 3, 4. Okay, and then from here you have 1, 2, 3, and 4. Okay, and then we start closing it. So this is what we start doing. Okay, now let's count the number of lines and see if this is correct. Okay, it's clearly not, but let's see how many lines we're missing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, and how many lines should we have in total? We should have a total of 28 lines. Okay, so we add a line over here. There you go. And then we add some lines over here to complete the pattern. Okay, now let's count the number of lines and see if we have a total of 28 lines or not. So 1, 2, 3, and make sure you guys do this in pencil. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there you go. We have now 28 dotted lines, 28 diagonal lines, sorry. And now the pattern is complete. And here what we have to do is we have to find an expression in terms of t for the pattern of short lines in pattern T. Okay. So we have 4, 10, 18, 28. So what's the first term? The first term is 4. What's the first difference? The first difference is 6. And if you look at the difference of the difference, you can see that's 2. So what's the difference of the difference? That's equal to 2. Okay, so let's write down the general term. So a plus n minus 1 into d1, which is 6, plus d2 upon 2 into n square minus 3n plus 2. And now we simplify. So we have 4 plus 6n minus 6 plus n square minus 3n plus 2. So here we have n square plus 3n. 4 plus 2 is 6. 6 minus 6 equals to 0. So there you go. N square plus 3n is your final answer. And make sure to check this. If I plug in 5, let's see if my answer is actually 40 or not. So 5 square plus 3 into 5. So 5 square is 25. 25 plus 15 is equal to 40. So there you go. And that's it. That's your answer. Okay. Now the next sequence is exponential sequence. Now again, this is also not very frequently tested. Okay. So in fact, so far I could only find one question here of this sequence. Okay. So let's do this. So let's say that you have 1, 2, 4, 8, and then following this, I ask you guys to write down the next couple of terms. Okay. You're welcome, Mustafa. I can see that you guys started a fight again. Okay, कोई बता रहा है? Next couple of terms. How many yearly past papers are enough? I really can't give you a number कि कितने काफ़ी हैं. You know, you can, once you reach a point where your score is stable and it's stable at a good score, ये नहीं कि अब आप 40% पे consistently 40% है और आपका यहाँ stable हो गया. You know, let's say अगर आप consistently 80% or above score कर रहे हैं, so that's good. Okay. Thank you, Mustafa. Thank you, Adnan. 16, 32, 64. Yeah, that's correct. 16, 32, 64. Okay. Yeah. So basically, this is called a doubling sequence. Okay. और इसको identify कैसे करते हैं? How do you identify a doubling sequence? Well, what you do is you find out the ratio. Okay. And what these terms have in common is a ratio. Okay, so these terms have basically something called a common ratio. Okay, let me give you one more example and then I'll tell you what I'm talking about. So let's say that you have 100 and then you have 10 and then you have 1 and then you have 0.1. Okay, so what are the next couple of terms going to be? So I'll let you guys figure this out. Tell me the next couple of terms. वैसे अभी जो लोग स्ट्रीम देख रहे हैं, what school are you guys from? Yeah, that's correct. 0. Okay, I think you've added one extra 0. So this is going to be 0.01. Okay, this is going to be 0.001. This is going to be 0.0001. Okay. So here also what we have is something called a common ratio. Okay. What exactly is a common ratio? So if you take any two consecutive terms, alright, any two consecutive terms, let's say you take these two terms, so 2 upon 1, and let's say you take these two terms, 8 upon 4, okay, and let's say you take these two terms, 64 upon 32. So what they have is the same ratio, and that ratio equals to what? And that ratio is equals to 2. Okay, so this is equal to 2, and it's the common ratio which is equal to 2, which is why we call it a doubling sequence. Okay, LGS, KGS, GP. What's GP? Bahria. Alright. Divisional public school? Where's that? Okay, now, so the common ratio is 2, and here if you do the exact same thing, 10 upon 100, which is equal to 1 upon 10, okay, which is equal to 0.1 upon 1. So in this case, you will notice that you get 1 upon 10, and your common ratio is 1 upon 10. Okay. Okay, how do you find the general term? The general term is basically AR raised to the power n minus 1. Okay, and what's A? A, as always, is the first term. Okay, R is the common ratio, and n is the required term. Okay, now, so let's do a question. Okay, I'm going to skip question number 7 part A part 1 and A part 2 because they revolve around the same sequence. Okay, and let's do part B. Part B says here are the first 4 terms of a different sequence. Find an expression for the nth term of this sequence. Okay. Acha, मैं कहीं नहीं जा रहा. I'm going to stay where I am. Okay, I'm quite happy where I am. So you guys can stop debating. So it says here are the first 4 terms of a different sequence. Find an expression for the nth term of this sequence. ठीक है? अच्छा. So पहले ज़रा numerator पे गौर करते हैं. So you have 2, 4, 8, 16. What does this look like? If you look at it closely, you will notice that 4 upon 2 is equal to 8 upon 4, which is equal to 16 upon 8. ठीक है? और ये सब किसके बराबर है? ये सब 2 के बराबर है. So that means this is basically an exponential sequence. अच्छा, now even though it's an exponential sequence, but you really don't have to use the formula over here. If you think about it, 2, 4, 8 and 16 are basically what? 2, 4, 8 and 16 are just powers. Okay? So you don't really have to use the formula. You can just see that these are powers of 2, and the general term turns out to be 2 to the power n. Okay. Now what about the denominator? For the denominator, you can use the formula for a geometric sequence, but again, you don't really have to do that, because if you sort of use a bit of common sense, okay, you'll realize that there's a strong pattern. Okay, and the pattern is this: 9 is basically square of 3, 16 is basically square of 4, 25 is basically square of 5, okay, 36 is basically a square of 6. Now you'll notice something. The term that you're squaring is always how many units greater than the term number. Okay, so think about it. The term that you're squaring is always how many terms greater than the term number. No, I'm not teaching A level in ISL. I'm not from Islamabad. No, wait, I'm not. That's in Lahore, so I'm not from Lahore. I'm from Karachi. Yeah, I agree. The chat is a total mess. Okay, no, it's not 1. It's 2. Okay. It's not 1. It's 2. The term that you're squaring is always 2 units greater than the term number. Okay, so that means if, let's say, you're on the nth term, then what you're going to square is n plus 2 whole square. Okay, and there you go. You now have the general term for the denominator also. And the final answer is this: 2 to the power n over n plus 2, the whole thing squared. And there you go. That's it. That's your final answer. Okay, I'll explain this again. So basically, what you have to do is, you can use the formula for quadratic sequence. Okay? If you want, you can totally use the formula for quadratic sequence. But if you use a bit of common sense, it will save you a lot of time. Okay? So the first term is 9, the second term is 16, the third term is 25, the fourth term is 36. Okay, 9, 16, 25, 36 are what? They're basically perfect squares. Okay? So 9 is the square of what? 9 is the square of 3. 16 is the square of what? 16 is the square of 4. 25 is the square of what? 25 is the square of 4. 36 is the square of 6. Okay. Now notice that the term that you're squaring, and compare it with the term number. You'll notice that the term number is always 2 greater. The term that you're squaring is always 2 greater than the term number. Okay. So when it's the first term, you're squaring 3. Okay. 1 plus 2 equals 3. When it's the second term, you're squaring 4. 2 plus 2 equals to 4. When it's the third term, you're squaring 5. Okay, and how do you go from 3 to 5? You add 2 to it. When it's the fourth term, you're squaring 6. So if it's the nth term, what's the term that you're going to square? You're going to square a term that's 2 greater than n. And what's 2 greater than n? N plus 2. And now you have n plus 2 whole square. Or what you can do is, like I said, you can use the formula for a geometric sequence also. Okay. So geometric sequence ka matlab, okay, what's the difference between 9 and 16? It's 7. What's the difference between 16 and 25? It's 9. And what's the difference of the difference? It's 2. Okay. So if you use the formula for a geometric sequence, this is what it's going to look like. 9 plus n minus 1 into d1, which is 7, plus 2 upon 2 into n square minus 3n plus 2. And then when you simplify this, this is what you end up with. N square plus 4n plus 4. Okay, so you can do it like this also. Now this is not APGP, but this is a quadratic sequence. Okay. Okay. Now I think I'm going to stop over here. Okay, and I will do another stream where we will solve just past paper questions. Okay. So let's keep this till here only. What do you guys suggest? Do you guys want to do more questions? नहीं हस्टैंड n square नहीं हो सकता because you're not squaring the term number. You're always squaring the term that's 2 greater than the term number. Is self-study better than school? It just depends on you. If you're disciplined enough, then yeah. Sir, एक joke सुनते जाएं. चलो सुनाएं. Okay, I'm still waiting for the joke. Okay, तो चलें एक काम करते हैं. Let's complete this. Okay, so let's do the hence find type questions. Okay, and then we'll end it, and then I'll do a different stream for past paper questions. Okay, so far let's do a quick check as to what we have done. So we've done this. We've done arithmetic or linear sequence. We've done quadratic sequence. We've done exponential sequence. Cubic sequence, I said that I will do it later. And as far as hence find and pattern recognition is concerned, let's do that. Okay. Sir, Israeli खरगोश को क्या कहते हैं? Okay, I know the answer. Rabbi. Okay. Now, इसको complete करते हैं, and then we'll call it a day. ठीक है? अच्छा. So let's have a look here. अच्छा. First of all, understand what hence find really is. So hence find is basically when you're given a certain sequence, okay, and you use that sequence to find the general term of some other sequence. Okay, I'll repeat. So hence find is basically when you're given a certain sequence and you use that sequence to find the general term of some other sequence. Okay. Now, okay, that was a good one. Okay, 1, 4, 9, 16. अच्छा, मुझे बता सकते हैं कि next couple of terms क्या होंगे? What will be the next couple of terms of this sequence? ठीक है. $25 and 36, that's correct. Good job. Okay, now if you notice over here, you can find the general term pretty easily. Why? Because what's 1? 1 is nothing but 1 squared. What's 2? What's 4? 4 is nothing but 4 squared. And what's 9? It's 3 squared. And fourth term is 4 squared. Fifth term is 5 squared. Sixth term is 6 squared. So what's the nth term going to be? The nth term is going to be nothing but n squared. Okay? Okay, so the nth term we have here as n squared. Yeah, we will call it a night, okay, but let's get through this, okay. We have some questions similar to this and then we'll call it a day, a night actually. Okay, now, the thing is, now here's what you guys have to do. You guys have to follow the sequence and see what's the pattern between this sequence, okay, and this sequence. So how do you go from 1 to 2? You add 1. How do you go from 4 to 5? You add 1. How do you go from 9 to 10? You add 1. And that means what will be the next couple of terms of this sequence? So this will be 26, this will be 37. So what is it that we are consistently doing? We are consistently adding 1 in order to get to the next term. Okay, what we're doing is we're consistently adding 1. And now, how will we find the general term of this sequence? We will do n square plus 1. Okay, what we do is we'll do n square plus 1 because we can see that clearly in order to get to the term of this sequence, from this sequence you add 1. So in order to get to the general term of this sequence, from the general term of this sequence, what we'll do is we will add 1. Okay. Achha, now let's do part B. Now for part B, I will do the working separately. Okay. Sorry, I meant part C. So part C, I'm going to rewrite the first term, the first sequence actually. So 1, 4, 9. So here's the working for part C. Okay, 1, 4, 9, 16, 25, 36, and then we have n square. So here's Tn, okay, and here's T6, T5, T4, T3, T2, T1. Okay, now let's write down the sequence of part C. Here it is. Okay. दोबारा ही लिख लेते हैं 3, 5 and then what do you have? You have 10 and then no wait 3, 5, 15, 24. Okay, now let's see what we do now. So how do you go from अच्छा wait a minute, I think ये 5 नहीं होना था, it should have been 9. Just a minute, Taro, let me just fix this. I think okay, this should have been 8 actually. Okay, let me double check. 2, 4, so yeah. Okay, so here we have 3, 8, 15, 24. Up say yeah. Okay. Now let's see what do we have. How do you go from 1 to 3? You add 2. Okay. And what's the objective? The objective is to use the sequence, use the general term of this sequence to find the general term of this sequence. Okay. So we're going to find the fifth term, the sixth term, and also the general term. Okay. Yes, we'll do some past paper questions, Iman, so you'll know exactly what this look like. Okay. And yes, Mohsin, usually in these questions they are related to each other. Okay. I'll give you we will do a past paper question so you guys will know exactly what I'm talking about. Okay. Okay, so let's start from the beginning. You have 1, 4, 9, 16, 25, 36 n square. Now how do you go from the general term of this sequence to the general term of this sequence? Okay, so how do you go from 1 to 3? You add 2. How do you go from 4 to 8? You add 4. How do you go from 9 to 15? You add 6. How do you go from 16 to 24? You add 8. Now the question is, how will you go from 25 to the general term, to the fifth term, sorry, of this sequence? What you're going to do is you're going to add 10. Okay, so if you add 10, what do you get? You get 36. You get 35. Sorry, and then what you're going to do is you're going to add 12. So what do you get? You get 48. So you get, now the question is, how will you go from the general term of this sequence to the general term of this sequence? Okay. So what we're doing is, look at the terms that we are consistently adding. Okay, I'll highlight them. You're adding 2, you're adding 4, you're adding 6, 8, 10, 12. Okay. So what we're going to do now is we're going to find out the general term of the terms that we are consistently adding. Okay. अब देखो हम क्या ऐड कर रहे हैं? हम 2 ऐड कर रहे हैं, 4 ऐड कर रहे हैं. In the first term we're adding 2, in the second term we're adding 4, in the third term we're adding 6, in the fourth term we're adding 8. Okay, just like that, if I want to find out what will I add in the nth term, what I'll do is I'll find the general term of the terms that we are adding. Okay, and finding the general term of this sequence is pretty easy. You can sort of see कि सीधा क्या होगा, 2n होगा. But let's say if you're not able to do that, so you can use the formula if you want to have a more formal approach. This is an arithmetic sequence because the difference is common. So 2 plus n minus 1 into 2, and now you have Tn, which is equal to 2 plus 2n minus 2. So this 2 and this 2 gets cancelled out. And now the general term of the terms that we are adding is 2n. So how do you get to the general term of this sequence? It's n square plus 2n, and there you go. That is your final answer. Okay. Now let's do some past paper questions of this. So here it is. Here's the question that I wanted to do. So it says here is another sequence 5, 8, 13, 20, 29. The pth term of this sequence is p square plus 4. Okay. Write down an expression in terms of p for the pth term of these sequences. Okay. So what you want to do is you want to first write down the sequence that's given to you 5, 8, 13, 20, 29. Okay, you add a few dots and then you write down the general term, which is p square plus 4. And then just underneath it, you write down the sequence of which you're supposed to find the general term. Okay, next thing what we do is we set off in finding a pattern. So how do you go from 5 to minus 2? You subtract 7. How do you go from 8 to 1? You subtract 7. How do you go from 13 to 6? You subtract 7. How do you go from 20 to 13? You subtract 7. How do you go from 29 to 22, actually it's not 27, you subtract 7. So what will be the general term of this sequence? The general term of this sequence will be p square plus 4 minus 7. Okay, p square plus 4 minus 7, which is p square minus 3, and there you go. P square minus 3 is your answer. Okay. Now let's do this. So here also I will do it the exact same way. So you have 5, 8, 13, 20, 29, and then the general term is p square plus 4. Okay, what you do now is you write down the sequence of which you're supposed to find out the general terms. So 7, 12, 19, 28, 39. Okay, now let's see what are the terms that you're adding. So you're adding 2 here, and then you're adding 4, and then you're adding 6, and then you're adding 8, and then you're adding 10. So how will I get to the general term of the sequence below? Well, I need to find out the general term of the terms that we are adding, which is 2, 4, 6, 8, 10, and the general term of this sequence is going to be 2n. So what's your final answer? Your final answer is that you're going to add 2n to p square plus 4. And when you do that, your final answer is p square plus 4 plus 2n, which you can write nicely as p square plus 2n plus 4. So there you go. P square plus 2n plus 4 is your final answer. 2p actually. Yeah, sorry. 2p. Thank you for that, whoever pointed that out. Okay, so that means we have now successfully done the hence find part also. Okay, now I will encourage you guys to solve the questions that we have in this that I have in this worksheet, okay, that I haven't solved, and then yeah, and then maybe I'll make a video or do a live stream some other day where we will solve some past paper questions. Okay, I think I'll make a video on it. Let's see. Anyway. Okay, so that's it for today, I guess. I will see you guys inshallah in the next live stream. If you guys have any questions, feel free to ask. Sir, do you cover all concepts in your number sequences series? So you can watch this. This stream covers pretty much everything. Okay. In fact, all the concepts except for cubic sequence, which, like I said, are very rarely tested, they're covered. Okay, next stream for math, let's see. I think I'll probably do it on probability, but most likely I'll be doing a stream on add maths. Let's see. Okay, so take care, boys and girls. See you guys in the next stream.